Give a round of applause to your host, Mr. Ellis. It's the Mr. Ellis Show.
Hey guys, we're going to do something a little bit different today. We're going to show you some things on this video, that way you have access to it at home if you'd like. But we're still going to talk about linear relationships and finding the slopes of lines. So we've got this graph here, similar to the graphs that we've looked at in the past. And we've already got 2 points here, and when we're talking about finding the slope of a line, we always talked about the change in y over the change in x, or you guys are more familiar with that phrase as rise over run. So we're going to do the same process here. First thing I always do is I draw my lines to get from one dot to the next. So I'm going to make my nice little arrows here. And then we can see we've got this triangle, the kind of things that we were working on the other day. And then I just have to find the values of those changes. And so for my rise here, we've changed 1, 2, 3, 4. And for the run, we changed 1, 2, 3. Now, before I go any further, one thing that I did want to say is this is going up to the right. And so remember when we're talking about positive slopes and negative slopes, if it's going up to the right, we have a positive slope. So it's okay for both of these numbers to be positive. From here, we simply have to do our ratio here of change in y over change in x, or rise over run. And so I would take that 4, and I would divide it by our 3. And this is our slope. We want to leave it as a fraction just like this so we can kind of understand what's going on here. We don't want to turn it into a decimal or a mixed number. Next, we're going to try a couple on your own. Alright guys, in that packet 4.2 that we got, turn to page 151, and it says on your own at the top, would you please find the slopes of these 3 lines? Alright guys, we're going to see how you did here. So for number 1, we're going to draw our lines with our little arrows, and you'll notice that this time the equation is going, the line is going down, so we know we're going to have a negative slope. So when I find this rise initially, it is a -1. The run here is 1, 2, 3, 4, 5. And so for my slope on this one, rise divided by run, I end up with -1/5. And we'd leave it just like that. That would be our slope. For number 2, once again, drawing our lines. Rise here is 2. Run, 1, 2, 3, 4, 5, 6. So for rise divided by run, or change in y over change in x, we end up with 2 over 6. And this is a positive slope. It's going up to the right, so a positive slope, so we're fine with a number like this, 2/6. Some of you probably simplified this a little bit, and sure, we could write an equivalent fraction or equivalent slope to this of 1/3, and that is 100% accurate as well. And then on this last graph here, draw our arrows. And so rise of 1, 2, 3, 4, 5. The run of 1, 2. So our rise over our run is 5 over 2. And once again, this is going up to the right, so a positive slope on this one as well. So those are the 3 answers you should have gotten, guys. Okay guys, now the next thing we're going to talk about is, we've talked about finding the slope of lines on a graph, but we also need to be able to find the slope of a line if we're given the information in a table. And here's how we're going to talk about that. We use the same concept for the change in y divided by the change in x. So when we're looking at this, once again, you guys know that as rise over run. We can do the same thing looking at this table here. So I look at what did my x change by, and I can choose any one of these. So from here to here, when it went from -1 to 0, that was a change of 1. And here, change in y, I need to use the same 2 points. So these 2 points right here. Y changed from -5 to -2, or an increase
L.A. Freed
in
to
3.
the middle school office. L.A. Freed to the middle school office.
From here, we use the same formula, change in y over change in x. The change in y was 3. The change in x was 1. So we'd write this as 3 over 1, which is 3, and that would be our slope for this particular table. Here's another example of a table that we're going to find the slope from. You're going to notice a couple things different about this particular table though. Still using our same concept. The change in y divided by our change in x, or rise over run, as you guys are more familiar with it. But here I want you to notice something. When I look at the change in x, and I can choose to go from 1 to 4, or from 4 to 7, or 7 to 10, any of those is fine. I'll choose 7 to 10 this time. That's an increase of 3, which is different. The other table was increasing by 1, so this is a little bit different. When I look at the y for that same spot from this point to this point, now we are decreasing by 2. So that's another thing that's different. Still use our same concept though. We're going to put our change in y divided by our change in x. So we end up with the slope of -2. That was our change in y from down here. Let me use green for that. -2 divided by our change in x, which was 3. And we're going to leave our slope just like that this time. So sometimes x is not going by 1s. That's okay. We can still use this. Sometimes y is increasing like last time, or sometimes it's decreasing like it was this time. That's okay too. As long as we use the change in y divided by our change in x, we'll get the right answer every time. Alright guys, now on that packet, we're on page 152. I'd like you to try to find the slopes for numbers 9 and 10 where it says on your own. Alright guys, let's see how you did. We're going to find our change in y over our change in x, or rise over run, from these tables again. Remember, it doesn't matter which ones you pick. I'm going to pick this one right here. That's an increase of 2. And y here is increasing by 3. Change in y over change in x. The slope of this table is 3 over 2, or 3 halves, and we leave it just like that. When we move over to number 10, we end up finding this one is increasing by 1s, and y is decreasing by 2s. For change in y over change in x, we end up with -2 over 1, which simplifies just to -2 as our slope. Alright guys, so we talked about finding the slope of an equation if we have 2 points on a graph, or if we have a table. The last thing I want to remind everybody about, and this is something you should tell yourself or ask yourself every time you're looking at equations, we have a line that's increasing from lower left to upper right, positive slope. If we have a line that's decreasing from upper left to lower right, negative slope. We got a horizontal line. Remember, that's a slope of 0. Okay, still has a slope, but it's a slope of 0. And this is a new one that we've recently kind of introduced. There are vertical lines sometimes that we talk about, and they don't really have a slope. So what we say is it's an undefined slope. Hopefully this works out for you guys, and let me know if you have questions.
Give a round of applause to your host, Mr. Ellis. It's the Mr. Ellis Show.